Becky has a biased six-sided dice. The table gives information on the probability that the dice is thrown, it will land on each number. Oh, okay. Becky's going to throw the dice 200 times, work out an estimate for the number of times the dice will land on an even number. Now, we know that all of the different probabilities will add up to 1, because that's the most they could add up to, or 100 if you were using percentage, but we're going to use 1. So we know that 2x plus 0.18 plus 2x plus 3x plus 0.26 plus x equals 1. I almost didn't fit that in. So 2x plus 2x plus 3x plus x would be 4x, 7x, 8x. And then 0.18 plus 0.26, I think it's 0.44. So now to solve this, and this is something you should have done many, many times, you take away the 0.44 from 1. I think it's 0.56, but I'm just going to check because, well, you never know. So it's 0.56. So we know that 8x equals 0.56. We also know that 8 divides into 56 7 times. So if we just divide that by 8, just to check. So we'll do what one of my favourite students does, just put the 8 underneath, and we get 700. So that means x equals 0.07. Now, if I was being really thorough, I would then fill this in. So this was 0.14, etc. I'm not sure I'm not sure you need to. Oh, no, you really do. So that's 0.14, this is 0.21, and this is 0.07. Now, work out an estimate for the number of times the dice will land on an even number. Excuse me. So go through and find the even numbers. So the even numbers are this one, and this one. And we're going to add up. So we get, so for 2, it's 0.18. For 4, it's 0.21. And for 6, it's 0.07. I don't think this is a fair dice. Oh, it is biased, yeah. 8, 9, 16, and 4, 6. So it's 0.46. Do bear in mind you can use your calculator for these things. I sometimes do, sometimes don't. And so she's throwing it 200 times, so you would say 0.46 times 200. So it's going to come in at around 92, I'm assuming. Here we go. 0.46 times 200 equals 92. So we're expecting her to land on an even number around 92 times, which doesn't make it seem that biased, to be honest, apart from the fact that the 6 looks pretty dodgy. Okay. This is a solid cuboid made from wood. When you see that, my immediate thought is, you're either going to find the volume or you're going to find the surface area. But the wood has a density of 0.7 grams per centimetres cubed. So I see the centimetres cubed, so I'm expecting that we are going to find the volume. So we know that 0.7 equals some sort of grams, the mass, over volume. There we go. So all we need to do now is find the volume. And how we find the volume is by going volume will equal width times height times length. So, or length times height times, so 12 times 8 times 5. And that gives us, I think it's 480, but I will do a quick check. 12 times 8 times 5 equals 480 centimetres cubed. Now, if we know that 0.7 equals mass, whoopsie-daisy, mass over 480, then we know that mass would equal 0.7 times 480. In fact, we should write that out. So 0.7 times 480 equals the mass. And then that means that the mass equals 336 grams. And that's already written in for you, so that's rather good, isn't it? Okay, let's have a little look what we've got here. Oh, good. Some some of this. Right, write 5.7 times 10 to the power 6 as an ordinary number. So you've got a bunch of, so you're going to do 5.7, and then you're going to put loads of zeros after this. I've been playing with this recently. And now we're going to go 6 this way. 1, 2, 3, 4, 5, 6. And that gives us 1, 2, 3, 4, 5, 6. Perfect. So it's actually that answer. I might just put in some... So that means it's 5,700,000. And then I'm going to get rid of that. Although one doesn't need to. Right, write 0.004 in standard form. So we're going 1, 2, 3 till we get to 4. So it's 4 times 10 to the negative 3. That goes in there. Oh, good Lord. Okay, so this is a plus. I don't know if you could just put it into your calculator. Essentially, I'm going to just write out what it says. So it says 2 times 10 to the power 4. So that's 2, 1, 2, 3, 4. So that's 20,000. Plus, I think that's going to be 300,000. 1, 2, 3, 4, 5. So that's 320,000. So if we did 3, 2, 0, 0, 0, 0 over... and that's not very nice. So that's 6.4. So that's 0.02. So that's going to make that really big. So 0.0064. Now, I'm just going to put it into my calculator and it's going to be horrible, I think. Let's have a look. 3, 2, 1, 2, 3 divided by 0.0064 equals... Right, I'm just going to count the number of... So, is it asking us to write it? Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There you go, 50 million. Which makes sense because there's 2 zeros there. So you're essentially saying times that by an extra 100. Okay, ooh, I like people buying boats. So... on the 1st of January 2016, Lee bought a boat for $170,000. The value of the boat depreciates by 8% every year, so it goes down. Work out the value of the boat 3 years later and give your answer to the nearest dollar. So what you're going to do is you're going to say her boat was 100%, and then we took away 8%. So it ended up as 92% after a year of what it was worth. We're going to make that into a multiplier by dividing it by 100. And then we're going to times the boat, or the amount that the boat cost, by 0.92. Now, if you just did that for 1 year, that would give you what she had by 2017. But if we do it times to the power 3, then we will find out what it cost on, or what it's worth on the 1st of January 3 years later. So times 0.92 to the power 3. And we're expecting it to be, I'd say, 140-ish. No, it's 132. 376.96, so it's 377. That's your answer. Right. Ooh, good.